Hello, today we'll be discussing the physiological changes in pregnancy. And the first one we're going to look at is the cardiovascular physiological changes. And at first, it is kind of, you think that is intuitive, but it's kind of more difficult to understand. So I'm going to take this time to explain it to you. Okay. So first off, we know that our pregnant woman has a baby in her stomach, or in her uterus more accurately, and that baby in her uterus has a placenta, and the baby needs blood supply as well. Okay, so normally a non-pregnant woman would have enough blood to circulate her entire body and to supply her physiological needs. However, she now has another human being made in her uterus and therefore needs more blood supply. Okay, so in a pregnant woman, majority of her blood volume goes to the uterus and her placenta. So I'm going to show you a picture of it. Okay, so here, this is a normal woman. We have enough blood supply to supply her entire body. In a pregnant woman, majority of her blood supply goes to the placenta, and we know blood is made up of mostly red blood cells. So her red blood cells are something like this. Okay, so her red blood cells are like this, and we know that red blood cells carry oxygen. Okay, so like I said, normally this would be enough for her to have, but now she's pregnant. Majority of her blood supply and her red blood cells with oxygen are going to the placenta. So she is losing her blood volume to the placenta, as well as she's becoming hypoxic because all of her oxygen is going to the baby. As a result of that, we need a mechanism to increase her blood supply and to increase her oxygen content. Okay, so her body, more specifically her kidneys, we know the kidneys are the prime organ. Her kidneys are supposed to detect volume level per se. So when the body detects a low amount of oxygen in her body, they cause the kidney to secrete erythropoietin. And erythropoietin is responsible for increasing red blood cell production. Okay, so that's number one. The second thing that happens is, since all of the blood is being shunted to the placenta, the kidneys itself receive less blood flow, and therefore it activates its renin-angiotensin-aldosterone system. So that's number two. So the renin-angiotensin-aldosterone system is being activated, and this aldosterone will cause increased absorption of sodium, and wherever sodium goes, water follows. So her plasma volume increases and her red blood cell mass increases. However, since her red blood cell mass and her plasma cell mass increases, there is a disproportionate decrease in her hematocrit. So if I was to draw this on the side there, normally our hematocrit is 45%, and everything above here is plasma volume. But in a pregnant woman, though her hematocrit increases by, her red blood cell mass, her RBC mass increases by 20 to 30%. Her plasma volume increase, which was activated by the aldosterone system, goes from 50. So the aldosterone system increases by 50%. So there is a disproportionate decrease in her hematocrit. So it's a false decrease in her hematocrit. Her red blood cell mass is increasing, but her plasma volume is increasing 50 times more. So therefore, there is a disproportionate decrease in her hematocrit. So if I were to write this down on the side there, we could see that her cardiovascular changes include, you have a increase in red blood cell mass and also an increase in plasma volume, right? But we have a decrease in hematocrit. So this would be increase for red blood cell mass, increase in plasma volume. So we have more increase in plasma volume than we have an increase in red blood cell mass. This will result in a decreased hematocrit. So that's the first thing. That's the first physiological cardiovascular change that happens. Moreover, remember the red blood cell we had with the oxygen. We said that majority of her red blood cells with oxygen went to the baby and to the placenta. Therefore, her carotid bodies, which were connected to the heart, received less oxygen. So they received less oxygen and less stretch, because we know that the carotid bodies have baroreceptors, and the more blood you have, the more stretch there is into the carotid receptors, and it will decrease the heart rate. But in the pregnant woman's case, more of her red blood cell mass was going to the placenta, so there was a decreased stretch in the carotid arteries, and therefore sympathetic outflow was increased to the heart and caused her heart rate to increase. So in a pregnant woman, her heart rate would increase. Okay, so that's one that will happen. Two, the other thing that would happen is that we would expect, since her heart rate is increasing, red blood cell mass is increasing, plasma volume is increasing, would expect that her blood pressure to increase. But in a pregnant woman's case, this is not what happens. We actually have a decrease in blood pressure. This decrease in blood pressure is due to the high amount of progesterone that she is producing. Now, progesterone works on the blood vessels and causes vasodilation. So these are the cardiovascular changes that happens in her. She has a decreased hematocrit, increased heart rate, and decreased blood pressure. The last thing that happens is that she has an increased cardiac output. And this makes sense. It's because since her red blood cell mass and plasma volume mass is increasing and her heart rate is increasing, we know that cardiac output equals heart rate times stroke volume. Okay, so her cardiac output increased because she has an increased heart rate, and stroke volume pertains to the mass of the red blood cells in the plasma. So there was an increase in the red blood cell in the plasma, so the stroke volume also increased. So therefore, it makes sense that cardiac output increased. Okay, and since her blood pressure, since her arteries vasodilated, that means there was a decreased afterload. So cardiac output increased for two reasons. One is because we have an increased preload, and two is because we have a decreased afterload. Okay, so we have an increased preload and we have a decreased afterload due to the high amounts of progesterone that cause vasodilation of the arteries, and the increased preload was due to the increased heart rate and also the increased plasma volume and red blood cell mass. So this has been cardiovascular changes in pregnancy, and I hope that was helpful.